Okay. Okay, so hello everyone. No, we're not going to use Craig because I'm recording this through OBS, by the way, so don't worry about it. Alright, so we're going to host statistics and probability today. We're going to mostly review the concepts and go through the concepts themselves. And we are not really, after discussing about how to host this session together with Malambo, we're not really going to have work examples for them. But after the session, you guys can definitely ask questions and stuff. And we're going to have we're going to give you guys a lot of questions for you guys to work on. So tomorrow, on Friday, you guys are going to have an extra session from us, basically where we can discuss about the questions that we gave you. So yeah, and the session is going to happen at 1 p.m. GMT, by the way, tomorrow, if you guys are interested. And if you guys have any questions, feel free to DM us during the course of after the session until the next session. So yeah, that's pretty much the stuff that we have for the session. Okay, so we're going to start with SL first, SL content. So first we have the difference between population and sample. This is pretty obvious. Population would be something like a big entire country, and sampling would be to take a subset of a small population of a small number of people from that population. And then we have several sampling techniques that we've learned: simple random, convenient, systematic, quota, and stratified. So simple random would be to literally randomly take anyone, and anyone has the equal chance of being chosen. Convenience would be to take samples from the members that you can easily take. Let's just say to sample people who came into the mall, like passing the brochures. And then we also have systematic, which is to take a sample for every K person. So let's just say in immigration, they're going to check people's security, make sure they don't bring anything illegal in the immigration every 10th person, something like that. Then we have quota. Quota is when you try to make sure that the number of samples have the proportion of your population. So let's just say if you have males and females, 55 and 45% respectively, then that means that in your sample, you're going to collect, let's just say if you want to collect 100 sample, then 55 of the sample is going to be filled with the quota of 55 males, and then the rest of the 45 will be filled with females. And for stratified, it's similar like that. They consider the proportions, but instead of taking samples without considering about randomizing them, this time stratified also randomized them. So in a subgroup, they would randomize. They do randomization to pick the sample. Okay, so this is I guess extra content, because I've never exactly encountered this in past papers or other questions. However, this is a part of the syllabus, so there are some errors in sampling and that data collection that you need to know, which is sampling error, random error, coverage error, having issues with covering target population appropriately, non-response error, when some samples are not responsive or they don't respond back. So there's a sampling, lack of sample, incomplete data. Measurement error is when you use the wrong tools to sample and measure data inaccurately. And we have discrete and continuous data. You should already know this. Discrete would be the data that are easily measurable, whole number, and finite. So something like the number of chairs, number of pencil, etc. And continuous are things that can take a full range of value and usually infinite. And they don't have they're not whole numbers kind of measurements, like let's say your height, weight, time, etc. Okay, so there are different ways to measure center of tendency. There's the mean, median, mode. I think these are things that you're already supposed to be learning, and you should, if you forgot about it, you can review back and look at the slide. It's pretty elaborate. And there are also different spread, different dispersions that you need to know. And the stuff that I guess let's just say we're going to learn as something new in the IB would be standard deviation and interquartile range. So in the IB, it's not really required for you to know the formula of standard deviation, but it basically measures spread through the mean value. So it's going to it's kind of like the means pair in terms of spread measurement. And for interquartile range, the dispersion pair of the central tendency is median. And there's also this thing called variance, which is the square of the standard deviation. And if you want to know why it's the square, you can just watch the supplementary knowledge video that I added. But yeah, basically you just need to know that it's the square version. And you should also know how to calculate the means and the interquartile range. It's in the formula booklet, so you should already understand and know them. And then these are some of the things for you to look back and recall. You're going to have cumulative frequencies. Q1, Q2, Q2 is median, Q1 is lower quartile, Q3 is upper quartile, basically 25, 50, 75%. And then there's also histogram and bar chart. Histograms are usually used for data that are in intervals, usually for continuous data, and then for bar chart is usually for discrete data. And there's also tables, which is quite obvious. And then we also have the box-diamond scatter plot. This is actually also very easy. Just if you look at the box, it has tails, right? It has a box, it has a tail, and then its tails, it's furthest stuff from the box is basically the mean and the maximum, and then the box shows the spread of the data. So the lower quartile, upper quartile, and inside there's the median. And we also learned that there's outliers, the data that's usually too far from the data that we have, that's considered suspicious. So you can calculate it using this formula. And yeah, so that's pretty much a roundup of those topics. And next we have Biferic correlations. So the first would be the line of best fit, which is basically if you have a set of values and then you want to plot them into a scatter plot graph, then in IB they're going to usually assess you in SL, by the way. In SL they're going to assess you to see if the data looks like linear equation, approximately linear, and you can easily just calculate this through your calculator's GDC stat. After making scatterplot line of best fit, you're going to have to Google line of best fit GDC, your GDC name for that. And for Pearson's product moment correlation, it basically tries to find how spread your data is general compared to the line of best fit. So it's usually best for a continuous variable, and basically if it's closer to the number 1, whether it's negative or positive, that means it's stronger positive correlation. If it's positive, it's stronger positive correlation. If it's negative 1, then it's strong negative correlation. And then 0 would be like, there's not really any correlation at all happening. So the Poisson product movement only tells you how spread the data is. Meanwhile, the Spearman's data tells you the monotonicity of the data. So basically, the Spearman's is like the Pearson's. However, when you're doing the Spearman's data, you're going to rank the data first in order. And to keep in mind to also, if there's a data that ties together, you're going to have to add the first and the next number and then divide them by 2. So like, if you have rank 2 and 3 that ties, that means you're going to have to put both of them as 2.5. Basically, like, you're seeing if your data number is increasing or not. And the range of values that you're going to have to measure to determine if it's like strongly increasing consistently or not is also using like the 1 and the -1 and the 0 range. Okay, so now we're going into probability. Probability is the chance or likelihood of an event happening. This is usually written as probability, parentheses, the variable, and in parentheses. Probability will always range between 0 and 1. So 0 would be like when it's impossible and 1 is certain. And then there's some terminologies that you need to know, like number of trials, outcomes, frequency, related frequency. Those are kind of self-explanatory. And then next, in probability, we tend to have different ways to depict the probability. We have lists, we have tables, tree diagram. In the case of this table, because it's 2 by 2, that's called a two-way table or a contingency table. And then for the tree diagram, it's very obvious. Like the branches shows the probabilities of getting what and what outcome and what outcome. And then for the list, they're just like listing down all the possible combinations that come up. And then we also have Venn diagrams. So in Venn diagrams, we have this U thing, which is usually like to depict like the entire data in the Venn diagram, like the universal data, the entire element, all of them. And then we also have, usually we have like numbers inside these Venn diagrams. Those are what you call as elements. And then we also have intersection, union, complement, conditional. Those are like Venn diagram terminologies. Intersection is basically what happens if you take A and B. A and B. So this part. A and B. Union is when you have like union combination of A and B. So like A or B. And then conditional is when you have A given the probability of getting, actually not the probability, sorry, my bad. Getting A when you're given B. So let's say like, okay, so let's say like here, you have, actually it's easier like here, okay. So you can see if you have given B here, and then you want to take A when you have B, then it would be this part. Yeah, so that's what they're saying. And then you have a bunch of formulas right here that's basically like, if you play around with Venn diagrams and like understand the basics of this, you would understand the next part. You just need to know like some of the terms, like mutually exclusive is basically two events that doesn't intersect, so they're completely two different events that never occur together. And then also complement. Complement is when like it's the opposite of a certain event. Next, we also have independent. Independent is when one event doesn't affect the other event. Yeah. Okay. And okay, so also this is like all of them are in terms of probability. So like you can definitely depict it in Venn diagrams, but the difference is that they're all written in probability. So like the sample space as U will always equal to 1. Yeah. And next we have some terms to remember in probability, like X as random variable and probability of X, like the big X equals to X, which means that the probability of getting the random variable X. This is applicable for probability distributions, and usually the important stuff that the foundations of knowledge that you need to know in order to be able to work on probability distribution questions would be the sum of probability of X would equal to 1. That, the stuff that we just talked about, and the expected value. You also need to know the expected value of the random variable X. So the expected value is basically like if you multiply the X by their probability and then you add them all up. That's kind of intuitive in the sense that like it's like finding the mean, but this time it's multiplied by the probability of it occurring. Okay. So next we have binomial distribution, where n is the number of trial and p is probability. So there are several assumptions when we're talking about binomial distribution. But when we talk about binomial distribution, we're talking about discrete variables that have a fixed trial. So there's always be a number of trials that exist. Like let's just say you toss a coin 10 times. Yeah, it's going to be like always 10, something out of 10 in that like scenario. And then the next assumption is that there's always 2 possibilities, only 2. It's like a success, fail thing, or black or white kind of thing. There's no in between. And then the next is that every trial is independent from one another. So each time you do the trial, their probability is going to be the same. And since that's the case, that means that like if you do a certain, let's just say if you coin flip, yeah, and then you toss, let's just say getting heads is like 0.6. And then that means that because the other possible chance of getting the other side, tails, is the opposite of getting heads, that means that it's always going to be 0.4, right? And then every trial, it's always going to be the same. Yeah. So you have to like know how to use the binomial PDF and binomial CDF in your calculator in order to calculate it. And there's also some formulas to find the mean and the variance, which is already in the formula booklet. Next, we have normal distribution. So normal distribution is a special distribution where the distribution is symmetric. So this bell curve thing, it's affected by the mean and the standard deviation. And usually the way we deal with it, because it's symmetric and because the mean and the standard deviation functions as like the thing that transform the graph, we can always like have a standard normal distribution of it, but we're not going to cover that a lot. But basically, like, because it's like the same shape all the time, but with like just different size, different stretches, or different positions, like in relation to the mean and the standard deviation. There's like this 68, 95, 77 rule. So if it's between one distribution spread, one standard deviation distribution spread, it's 68%. 2 would be 75%, and 3 would be 99.7%. Also for like norms CDF, normal distribution CDF in the calculator, you have to keep in mind that the calculator always only gives answer from the left side. So from left here to right. So you have to keep in mind when you're like trying to calculate it. Okay, next we have parameters, distribution, hypothesis. We're going into hypothesis testing. So parameters is basically like the measurements, the terms that we give to like mean, standard deviation, probability, correlation coefficient, those kind of like numbers. And then we have distribution. So there are a lot of different distributions. Like we see before, there's binomial, normal distribution, later Poisson for HL. And we also have the hypothesis, the null hypothesis and the alternative hypothesis. So the null is usually that one hypothesis that we need to falsify when you're doing hypothesis testing. And the alternative hypothesis is the hypothesis we want to test to see like if it can be accepted if the null hypothesis is rejected. We also have one-tail test and two-tail test. So one-tail test is basically like if you're only looking for one side of this thing that's shaded. Two-tail test is when you're looking at like two sides of it. So this happens if two-tail test is what happens if you're not sure if your data is going to be like outside the data that's like outside the higher area or the lower area. And one-tail tests have like they can be like the right side only or the left side only. So it depends on your hypothesis test. So let's just say if you want to find whether the average of your weight the average of my weight compared to my classmates is higher, significantly higher than like the average in my classmates, that means that you're going to test the upper part of the distribution. So, or if you're trying to test like if my shoe size is lower than average, significantly lower than average than the average population, then we're testing on like the lower side, one tail. If you're sure about like whether it's lower or upper. But if you're not sure, we do the two tail. Yeah. And then we also have significance level. So significance level is like how confident you want to be with your data. So let's just say the average, the standard significant level that we use usually is 5%. So if we have 5% significant level, that means that we're 95% confident that our results are going to be right. So like if we do like, let's just say 100 times testing to see, 100 times of testing to see if your results are true or not, then it would be approximately 95% of those tests you will be right, but 5% you will be wrong. Next we have critical region. Critical region is like the value that you need to pass in order to falsify your null hypothesis. So in the case of two-tailed, that's the blue critical value. Then finally, p-value is the probability of obtaining your result when the null hypothesis is true. So it's like to test if how likely are you going to get the result if we follow this distribution. Mm-hmm. Okay, so now we're going into HL level. Okay, so this is, oh yeah, actually before we go into HL, we can probably just like have a little, like a short break where we answer your questions if you guys have any in the concepts. Okay, we're gonna do a 5-minute break for questions. Okay, if there's no questions at all, oh, unbiased estimator is going to be for HL. So we're going to cover that later, actually. I mean, this will probably last around 1.5 hours, and then after the session, I'm probably gonna stay around for a while, and if you guys want to work on some questions, I don't mind accompanying you guys and help out, because I personally don't have a tablet. My last tablet broke, so I can't really do any direct demonstration of the. Okay. Yeah, but I'm up to help accommodate you guys and discuss about anything you guys are struggling with. Sorry if I missed this part, but did we discuss whether it is accepted or rejected based p-value and the significance level? So if so, can you repeat it? Okay, so basically, oh, someone's echoing. Oh, Mo, can you mute? Because it's kind of echoing in your. Okay, I'm sorry. Okay, so whether it's accepted or rejected based on p-value and significance level, kind of this is for this is for SL though, right? For SL, you guys are going to learn about chi-square test and the t-test. Usually for if you're computing stuff on your calculator, you can just get the p-value right away, very easily. So you don't need to worry about the critical values or the critical scores, unless if the question is asking you guys to use the critical values or the critical scores. So the critical values or critical scores are usually okay, this is for normal distribution, but it can also apply for other distributions from chi-square test and t-test. So if we have this kind of thing, and we have a critical value, the critical value is going to determine using your other critical value, value from the distribution. Let's just say for normal distribution, it's the z-score. So we have a z critical value, and then we have a z critical value, z-score, and the z critical value is going to determine whether you're going to reject or accept a null hypothesis. So for let's just say if we have this, then the critical value, I think this critical value is approximately 1.5 and minus 1.5. That's the z critical value. So you want to get a value, a z-score value that's between minus 1.5 and you wouldn't want to get a value that's between minus 1.5 and 1.5. So you want to get a value that's above it, beyond it. So let's just say if you want to test if you're on top of the 10%, if you're above the 10% score, that's above, right? And you want to pass the 1.5 threshold. That means that for the z-score, you're going to have any value above 1.5. As long as it's 1.5, you can reject the null hypothesis. That's kind of how it works. The same goes with like t-test. Like usually t-test, if you compute it manually, they have this t critical value in which you can in which you have to go past it, exceed the value. If you can exceed the value, you're going to be able to reject the null hypothesis and basically accept the alternative hypothesis. But like that's not really necessary for you guys to know, because in the in our exams, we're going to use our calculator and GDC, right? So we just need to know whether the p-value is 0.05 or lower than 0.05 if you have a 5% significance value. Or if you have a 10%, then it's going to be 0.1 or less than 0.1. So you just look at your p-value and see if it's lower than the significant value. Okay, can you explain the general confidence interval equation? Yeah, that's general confidence interval. Oh, I think that's not going to be covered here, because basically the equation is like syllabus-wise. It's not really something that you're supposed to know, because you can just calculate it through your calculator easily without like computing the formula. Will you be going over an example where we can see the p-value in effect? Because I forgot how to do this in calculator. So do you mean like do you want us to go through an example where we do a p-value past paper involving p-value? Is that what you're saying? Okay, we'll keep that in mind. Okay, actually, might as well pin this thing. So can you look back to it again? Yeah, cover it. So if you guys don't have any questions, we're just going to continue to HL. SL is actually done. But like, if you guys want to stay like till after the session, we can also cover SL questions too. Okay. I guess we can proceed. Okay, we can proceed then. Next, I'm gonna like just, this is also something that's like also in the syllabus apparently, but we're not, basically like, you can like read this yourself and it's kind of self-explanatory. I don't know if it's going to come out in questions, but it's just like mostly theories, and we've never encountered that in past papers, so I don't know. I'm just putting that out there in case. But like later, if you guys want to ask like to clarify some of the terms, or just ask right now, I'll just help you guys clarify what they are. Okay, next we have Gina explaining about validity and reliability. Okay. Next we have Biferic Correlation. So honestly so the first is that we're going to have for HL we're going to have nonlinear regression. For nonlinear regression, there's not much that you can do calculation wise. However, you're expected to know where to find it. It's in the same area as the part where you try to look for the linear regression, but this time you need to know which one is quadratic, which one is for exponential, which one is cubic, which one is sinusoidal, and which one is power. So it's just input calculator and know which one is the R squared, the correlation of determination, and we'll cover that in the next slide. That's literally pretty much it. There's nothing, because we're not taught to how to calculate the rest. So now we talk about R squared, and well, there's also a supplementary video on R squared and its residual. So how the formula of 1 minus s as residual over sum of squared total came to be. That is also something that's outside the syllabus. So if you guys are interested to know, it's actually not that hard. You guys can try to watch the video. So the R squared tries to measure how well the data predicts the data X predicts the data Y from the line of best fit. So it has the assumption that the data X and Y can affect one to another. So it's not just a correlational thing. This can be found for any kind of regression models that you have out there. Any of these, all of these, they will always have the R squared, but they won't have the R value, because the R value is the Pearson's correlation thingy. It's only for linear correlation. This time it is on a scale of 0 to 1. So if it's 1, then that means that the best model that you have, the best fit of line for the data that you have, can predict the data set perfectly. And if it's 70%, then it can predict it correctly 70% of the time. So the less R percentage it has, R value it has, that means the worse the data is at predicting the worse the model is in predicting the actual data. Yeah. So next we have Poisson distribution.
Even if the expected value was the same, the variance is different. That's because, for example, you can think of it as a way,
It's okay, you're doing great.
Okay, so there's example is to be combining multiply distributed variables. So here's like a question how to do. We can attempt to do this question later on after the session ends. And this is another type of and there's another type of question which is combining equals. But the logic overall is the same as like the combination
just like to add up, I guess. And easy, at least how I like usually remember type 1, type 2 is I remember them as false positive and false negative. I don't know, because like the term is just easier to remember if you say false positive, false negative. So like false positive is when, yeah, false positive is when you thought that you should accept the null hypothesis, but turns out you're not supposed to accept it. You know, you got positive, but apparently it's wrong. And then type 2 is false negative because it shows that it's insignificant when it's actually significant. Okay. Now we're going to transition matrices and Markov chains. Okay, so transition matrices and Markov chains are kind of to a tangent related extent to matrices and eigenvectors and eigenvalues, but we haven't really covered that in the session, like in any of the sessions at all. So basically, transition state diagram is that like that one picture where you draw the movement of things of every transition from like one variable to another, or like if there's 3 or 4 variables. So in here we have the example of 2 variables, and like I think this is like pretty self-explanatory since like this goes back to part R. This means that it goes from S to R. This goes from R to S. Now, if I recall correctly, people are struggling, at least like from what my teacher said, people are struggling with mapping like the transition state diagram to the transition matrix. So there's actually different ways to write this. Like there's the from to, like in this format, and then there's the swap format. But basically in IB, we're learning it in this format. So just stick with this format. Well, in adjacency matrices, I think you will have the swap version, but like those are, just think of it as like 2 different concepts, 2 different things. Like transition matrices, for transition matrices is going to be from at the above and to at the side. So R to R, S to R, R to S, S to S. You just input the values. It's that simple. Usually, like you would be given a set of like populations. So maybe at first, the first time the part open, you'll have around 100 people going to part R, and then 150 people going to part S. That's going to be the initial state. So the initial condition of the population, because transition matrices basically like help you see how the population, the same people will like switch around from the 2 different things in the long run, assuming that the participants are the same participants, and also assuming that the probability is not changing, and like there's no change. They're just trying to look for the long term. So since we can use our calculator, we can always just like input this in terms of matrices easily. You can also input the squares easily through the calculator, and you can also find the long-term transition matrix state. So basically, in order the long-term state, in order to find that, you can just input this n number into 50. Usually, if you input 50, it's definitely going to get constant. If it's not constant, then you need to, like, if there's something wrong with your data and you can't get like the constant same number in the long run, that means that there's something suspicious with your numbers. Because the thing with transition matrices is that from the same part, in this case, it's going to be always adding up to 1, the probability of it. So it's like the chances of going to R, moving from R, the chances of going to R or staying in S, they have their own probabilities, and they have to all like add up to 1, because like the choice of someone from part R into like the next day is to either go back to R again, or the choice is to switch to S. And the same goes with, yeah, so they add up like downsides here. And there's also the steady state, that is also which is like can be calculated the way I said before using calculator, or you can also calculate it by solving simultaneous questions. So from here we know that like if you studied matrices, you would know that this can be transformed into simultaneous equations. However, there's another important like simultaneous equation that you need to know that should be included here, which is the x plus y equals to 1. X plus y equals to 1. This is important because if you don't add it, you're not going to really get any results. So you can easily input this in the simultaneous equation solver, but as you may know, the simultaneous equation solver has like only 2 slots, right, for something like this. So you can just discard like either this equation or this equation and like put in this part and either of these parts. Oh yeah, and by the way, before you put it in, you have to make sure that all the x and the y's are in one place. So like, for example, for the first equation, you have 0.6x plus 0.3y equals to x. That means that you have to move x to the other side to make sure that x is like only one variable. So that becomes 0.6x minus 1x plus 0.3y, and that would be minus 0.4x plus 0.3y. So the stuff that you're going to input is minus 0.4, 0.3, 0, and then 1, 1, 1. That's how you're going to find it. There's also another way for you to calculate this-ish through the eigenvectors and eigenvalues, but we haven't really covered that. So I don't think it's a good idea to like bring it up unless if you want us to cover that later when we talk about the questions. Yeah, so that's all for the concepts. Okay. So from here, I guess you guys can ask any questions, or like if you guys have any requests to go through anything you guys are struggling with, we'll be happy to help. And it seems like some of you guys have suggested some stuff, right? So we will definitely get into that. Okay, so someone asked a question before. So since we are able to use a calculator, we can dismiss the whole critical value thing. You just need to understand what critical value is, like that's it. You do, like, for finding the you need to know the concept of critical value, and like sometimes they would ask the chi-squared test value, but I'm not sure if that's like actually in our syllabus or if that is from the previous syllabus, because it's like it's very messy with the entire syllabus change thing, but like it's not that hard to understand, or maybe I just didn't explain like it well enough. But yeah, we still need to know what critical value is, because I've ever seen questions being asked before regarding critical value, and like sometimes they also ask the chi-squared critical values, and whether that rejects the null hypothesis or accepts it. So yeah, you still need to know about them. Okay. Yeah, so basically, like, concept-wise, we're pretty much done, but I'll still stay here to, like, help you guys work on some stuff. Okay. Thank you.